Hello friends, here is Mr. Ramesh Chandra, did BTech from IIT Kanpur and taking lecture second on complex numbers. This is useful for CBSE and HSC board as well as the student who are preparing for IIT JEE main and advanced. So let's start with the algebra of complex numbers. As we know, algebra is the addition, subtraction, multiplication and division. So here we will learn how to add, subtract, multiply and divide two complex numbers. So let's say Z1 that is equal to 2 plus 3 iota. This is the representation of complex number, that is 2 plus 3 iota. And let's have another complex number Z2 that is minus 1 plus 2 iota. Let's say we have these two complex numbers. So if we need to add these two complex numbers, so Z1 plus Z2 is equal to 2 plus 3 iota and plus minus 1 plus 2 iota. As you can see here, what we do is we add real part by real part and imaginary by imaginary part. So 2 plus minus 1 is plus 1 and 3 iota plus 2 iota is 5 iota. 5 iota. So let's have another example. We need to add something like 2 minus 7 iota plus 7 minus 6 iota. So what we do is we just add 2 plus 7, these are two real parts, add real by real, and plus iota times minus 7, this is minus 7 and minus 6, so this is 9 minus 13 iota. So this is the addition of two complex number. Let's say in general, if we have Z1 is equal to A plus iota B and Z2 is C plus iota D, then Z1 plus Z2 is same as the addition of these two, A plus C plus iota times B plus D. So this is the addition. In the same way, let's have subtraction. This is very similar to addition. So let's say Z1 is equal to 5 plus 4 iota and Z2 is 3 plus 2 iota. Then Z1 minus Z2 can be written as 5 plus 4 iota minus 3 plus 2 iota. 3 plus 2 iota. So this can we have 5 minus 3 plus iota times 4 minus 2. That is 2 plus 2 iota. So this is the subtraction of two complex numbers. In the same way, if we have Z1 and Z2 as these two complex numbers, then again Z1 minus Z2 can be written as A minus C plus iota times B minus D. Let's move on the multiplication of complex numbers. Let's understand multiplication. So let's have Z1 as 3 plus 2 iota and Z2 as 5 minus iota. Then Z1 into Z2 can be written as 3 plus 2 iota into 5 minus iota. So first thing we need to understand how to multiply them. This is very similar to the multiplication that we have like A plus B into C plus D. So we first multiply by C, that is AC plus BC, and then multiply by D, that is AD plus BD. In the same way, we multiply here by 5 in both the numbers, that is 5 into 3 plus 5 into 2i, and this is minus 3 into I plus 2i into minus I. So this is the multiplication. So we will get 15 plus 10i minus 3i, and here we are getting minus 2i square. And we learn I square is minus 1. So if we multiply this by, that is 2 and minus 1, that is minus minus, that is 2. So the addition of these four numbers will be 15 plus 2, that is 17, plus 10i minus 3i, that is 7i. So multiplication of these two numbers is 17 plus 7i. You can also do it in a very short way, that is 3 into 5, that is 15, and here we are getting minus 2i square. So minus 2i square is plus. So what we have, short trick is 15 plus 2, that is 17. So we have written 17 as real part. Now how to get imaginary part? So this is 5 into 2, that is 10i, and here we have 3 into minus I, so minus 3i. Hence 10i minus 3i is 7i. So we will get this as a product in short. Let's have another example. Let's multiply another two complex numbers like 4 minus iota minus 2 iota into 3 plus 5 iota. So let's multiply in one line. So what it is? 4 into 3, 12, 4 into 3, 12, and 5 into 2, 10, and minus I square. So minus 10i square, that is plus 10. So this become the real part. And what about the imaginary part? So let's I times, if we multiply 4 by 5 iota, that is 20i, and 3 by minus 2 iota, since we have already written plus I here, so we will write minus 6 here. So what we are getting? 22 plus 14 iota. Let's have another multiplication. 5 plus 7 iota into 3 minus 2 iota. So what we will have? 5 into 3, 15. 7 into 2 is 14 minus 14i square. So that is plus 14, and that is 3 into 7 iota times 7 into 3, 21, and here 5 into 2, 10 minus 10i. We have already been taken common. So here we are getting 29 plus 11 iota. So this is the multiplication of two complex numbers. Let's move on the division. Before moving on division, let's understand some facts. If we multiply 2 plus 3 iota by 2 minus 3 iota, that we are getting here is 2 into 2, that is 4, and 3i into 3i is, that is 9i square, minus 9i square, so that is 9 plus iota times 2 into 3, that is 6, and here is minus 2 into 3i, that is minus 6. So what are you getting here? 13 plus 0 iota, and 13. 13 is a purely real number. Again, let's have another case. 5 plus 4 iota multiplied by 5 minus 4 iota. Now this time you can apply a plus b to a minus b formula, as we can have a square minus b square. So let's apply this formula here, that is 5 square minus b is 4i. So this is 4i whole square. So what we are getting here? 25 minus 16 I square. I square is minus 1, so 25 plus 16, and this is equal to 41 in addition, which is a real number, positive real number. And these two are complex conjugate of each other. Later on we will understand, we will explain what is complex conjugate. So if Z is 5 plus 4 iota, then its conjugate is represented by Z bar as 5 minus 4 iota, and it obtained by replacing I by minus iota. So if we replace I by minus iota, we will get the conjugate. In the same way, any number a plus iota b and a minus iota b, that is a, b belongs to real, are conjugate of each other. So if we multiply a plus iota b by a minus iota b, then you will get a square minus iota b square, that is a square plus b square. So you can observe a square plus b square, this is positive real number, and you are observing here the product of two complex number is purely real number, and this become the cause of division. To have rational number in the denominator, we multiply numerator and denominator by its conjugate. Let's understand by an example. 5 plus 4 iota divided by 3 minus 4 iota. So we know the fact, if we multiply 3 minus 4 iota by 3 plus 4 iota, then this become purely real at the denominator. That is 3 plus 4 iota into 3 plus 4 iota, that is complex conjugate of this number. So this is equal to, we need to multiply this by 3 plus 4 iota, that is 5 3 ja 15 and 4 4 16 I square, that is minus 16 plus iota times 4 into 3 12 plus 4 into 5 20 upon, we know this as this is a square plus b square, as we earlier derived the formula a minus iota b into a plus iota b as a square plus b square. We recently derived this formula. So this is 3 square plus 4 square, and this is equal to minus 1 plus 32 iota divided by 25. So we can write it as minus 1 upon 25 plus 32 upon 25 iota, and this is of the form a plus iota b form in which a b belongs to real. We call this form as a plus iota b form. So what we get, if we divide 5 plus 4 iota by a complex number 3 minus 4 iota, we will get minus 1 upon 25 plus 32 by 25 iota. Let's have another example. Let's say minus 1 plus 2 iota need to divide by 6 plus 5 iota. So what we do is, we have minus 1 plus 2 iota. To get a rational number or real number, purely real number in the denominator, we need to multiply by conjugate of this, that is 6 plus 5 iota need to multiply by 6 minus 5 iota. So this is 6 minus 5 iota, that is minus 6 and plus 10, 5 into 2 10 minus I square, so plus 10 plus iota times 2 into 6 12, and this is plus 5. This is the multiplication at the numerator, and at the denominator we will get 6 square plus 5 square as per the formula. So here we are getting 4 plus 17 iota by 36 plus 25, that is 4 upon 61 plus 17 iota upon 61. So this is of a plus iota b form, and this is the division of minus 1 plus 2 iota by 6 plus 5 iota. Let's understand the term additive inverse, and second one is multiplicative inverse. So what is the additive inverse and what is multiplicative inverse? If we have a complex number z, then we need to add something to get the same complex number z. You can see if we have the equation like z plus add something that is equal to z, then you will get z plus 0 is equal to z, and where 0 is equal to 0 plus 0 iota, and we call this as identity element. So identity element for addition. Now we have z plus a complex number z1 as 0, then z1 is equal to 0 minus z, that is minus z. So z1 is equal to minus z is called additive inverse. Additive inverse. So in general, we can have z plus minus z is equal to 0. So this is the additive inverse of z. Now let's talk about the multiplicative inverse. Here you can observe, if we multiply z by a complex number, something that remain the z, this is what we call identity element. Here you can observe z into 1 is equal to z. So 1 is what we call identity element. Now if we have two complex number like z1 into z2 such that their product is 1, then z2 can be written as 1 upon z1, or z1 can be written as 1 upon z2, and this can also be written as z1 to the power minus 1, and this can be written as z to the power minus 1. So here you can observe that z1 and z2 are multiplicative inverse of each other. So what is multiplicative inverse? If we have 2 plus 3 iota as a complex number, and if we multiply a complex number z such that its multiplication is 1, then z is known as the multiplicative inverse of 2 plus 3 iota. And hence we can write z1 z as 1 upon 2 plus 3 iota. So this is similar to the division of 1 by 2 plus 3 iota. So multiply by 2 minus 3 iota, numerator and denominator 2 minus 3 iota, and that is 2 minus 3 iota divided by 13, and that is 2 plus 2 upon 13 minus 3 upon 13 iota. Let's understand the algebraic identity and complex number. Here we will learn how to apply algebraic identities in the complex numbers. Like we have algebraic identities as a plus b whole square, then it can be written as a square plus b square plus 2ab. In the same way, we can have the same identity in the complex number as if we have 2 plus 3 iota whole square, then we will have 2 square plus 3 iota whole square plus 2 into a is 2 into b, that is 3 iota, and so this is equal to 4 minus 9, 3 square I square, that is minus 9, and here we have 4 into 3, 12 iota, so that is minus 5 plus 12. So square of 2 plus 3 iota is minus 5 plus 12 iota. Let's have another identity like a minus b whole square, that is a square minus 2ab plus b square. You can apply this. So if we have like 5 minus 4 iota whole square, then we can write it as 5 square minus 2 into a, 5 into 4 iota plus 4 iota whole square. So you will get 25 plus 4i whole square, that is minus 16. Here you will get 5 into 2, 10 minus 40 iota. So this is 9 minus 40 iota is the square of this. Even we can have a plus b to the power 3 identity as aq plus bq plus 3a square b plus 3a b square. So if we have a complex number like 1 plus iota to the power 3, then we can have 1q, that is 1, and b, that is iota q, that is minus iota, and 3a square b, 3a square b is plus 3 iota, and plus 3a b square, 3a b square, that is 3i square. So this is minus 3. So this is equal to minus 2 plus 2 iota. So here you can observe that we can apply algebraic identity in complex number as well.